new episode of AI Chronicles, everyone. As you know, we are surrounded by a ton of unstructured data, whether it's text, images, audio, video, etc. Video data is essentially could be hard to process and work with. And since I don't personally have much experience in building or applying any computer vision algorithms or techniques, I invited the head of developer experience, James Lee, from a company called 12 Labs, who, by the way, just raised a Series A. Congratulations to the entire team. And hi, James. How are you
Yeah,
doing?
good. Yeah, thanks for the invitation, Sonam, and super excited to have this conversation with you.
Absolutely. So, without further ado, let's get started. I have some fun questions prepared for you, mainly because, I am curious about how the whole computer vision and multimodal and all those different algorithms work. So the first thing I would like to ask is let's talk about multimodal AI. What
Mhm.
are your thoughts over it?
Sounds great. Yeah, so uh, I think a very short and brief description of multimodal AI is that is a very exciting research frontier that combines multiple data types like text, image, audio, video, as well as other form of modality as
Hmm.
well to enable more comprehensive and contextual understanding, right? And this is super exciting for the whole AI research direction because multimodal AI very closely mimics how us humans perceive the world by integrating information from different senses, right? So if you think about
Hmm.
like a newborn baby, if they were born, they probably to like acquire knowledge, they have to you know see things, they have to feel things, they have to sense, touch, and as well as read. So they activate all this senses, right, during the first few
Hmm.
years of their life in order to acquire knowledge and gain that intelligence. Um, so same principles here with multimodal AI that allows uh, machine learning AI models to pick up on nuances and connection that unimodal AI for
Hmm.
system that only focus on a single modality may miss. So yeah, at 12 Labs, we've been super interested in the potential of multimodal AI since the beginning, especially with regarding the context of like how we can combine video data with other data
Hmm.
types, to enable powerful new application and experiences. And the reason is that video provides a very rich information stream that can significantly enhance AI capabilities when being combined with text, audio, etc.
Hmm. Yeah, that's very well said. So, I am familiar with the text side, like the text mode part of the whole multimodal AI. But I am curious, like if you were asked, like if I ask you, like how would you walk us through history to the current state of computer vision? Or in other words, let's say, where did we start from and where are we now?
Mhm. Sounds good. So I think to get started with computer vision, well, overall, I think the whole field has made a lot of like remarkable progress, right, over
Mm-hmm.
the past several decades. Some of the early work is back in the I say the 60s, really focused on very basic algorithms for edge and shape detection, and
Mm-hmm.
then around the 90s, we see techniques around like OCR, like optical character recognition, being
Right.
used for variety application. And the first type of techniques for this is the LeNet algorithms by Jan LeCun, right? The first like convolutional neural nets
Yeah.
introduced in 1998 when he was
Mm-hmm.
a scientist at Bell Labs, if I'm correct. And so in
Mm-hmm.
the 2000s, the whole like since the beginning of like the 21st century, you really see the whole field took off, right? With the rise of convolutional neural networks, especially with AlexNet in 2012, and we start seeing that it being adopted with a variety of architecture, right, ranging from like MobileNet to DenseNet, ResNet. Like if you like
Mm-hmm.
a researcher in AI field throughout the 2012s, you definitely become aware of this development. And one particular resource that I highly recommend for any let's say students or newbies to CV field is the CS231 classes taught at Stanford. I recall when I first got into the field, I watched lectures online. It was taught by like Andre Kapati and
Mm-hmm.
Fei Li, who like all these like well-known figures in the field, and it's extremely useful regarding the mathematics and the theoretical aspect of like how this model works so well.
Mm-hmm.
But yeah, back to my thread is like besides the algorithm development, you see also the increase of compute power with like
Mm-hmm.
new hardware, right? NVIDIA invests a lot of effort on the hardware side of things that allows researchers to train this model on better device. And then the final part of the equation besides algorithms and hardware is the data part, right? So the
Mm-hmm.
availability of large label image data set, right? We all know the ImageNet was created like in the early 2010s, but like ever since then, there's been more effort being invested in like collecting even more diverse like computer vision data ranging from image to video.
Mm-hmm.
And the combination of all of these factors enhance significant advances in um, computer vision application that can accomplish different capabilities, right, ranging from let's say facial recognition to object detection to image classification to like semantic segmentation, right? And we're
Mm-hmm.
definitely seeing this sort of task, these tasks power a lot of different applications, ranging from let's say autonomous vehicles to medical imaging to like retail experiences. Um, and with that sort of overarching history, I think I want to give a short probably paragraph about video understanding, right? So I think I actually wrote a whole blog post on this topic, but the way we see video understanding is in the past and the present. The past really focused on some low level video perception tasks that I literally just mentioned earlier. And then now with the rise of like foundation models, we are seeing uh, people build model to sort of higher level understanding tasks, from semantic search to question answering to let's say chatbot with a video. And let's say in the future everything will become multimodal. It's just a single model that can um, you know uh, that exists like general purpose video understanding
Mm-hmm.
capabilities, right? Everything ranging
Right.
from analyzing single frames to like have a interesting conversation with the video itself, and this opening up huge opportunities for the type of application that people can build with, but also like pose a lot of different challenges in terms of like especially around the infrastructure side, how we can efficiently uh, you know build the type of model that can process very large amount of like video in like a single instant, right? Yep.
Mm-hmm. Mm-hmm. Nice. That's a great walkthrough. I mean, I've heard of all these algorithms, even tried a little bit, but like getting like the whole um, history walkthrough is very essential, I think. So
Mm.
yeah. So you mentioned some of the the convolutional network, neural network, and other algorithms as well. So speaking of those, like what are some of the video foundation models that engineers and scientists are really fond of using? And if you can tell me why, that would be
Yeah,
great as well.
sounds great. So in academia, some of the most popular video foundation models include um, I3D, slow fast, transformer, and video swing transformer.
Okay.
Some of I actually wrote a whole blog post on this topic on the 12 Labs website last year. So if you, I can link that into the show notes. And for anyone
Hmm.
who's interested in going down deeper,
Yeah.
some of these, actually achieve state-of-the-art performance on different benchmark on the during the time period that they was released, right? So what makes some of these model very powerful is that they can learn very rich spatial temporal features within a
Hmm.
video by processing
Hmm.
not just like individual frames, but also sequence frames, right? And this allows them to capture motion understanding as well as any like temporal changes, right? Which is very critical for video understanding. Um, and I just want to emphasize this: like video understanding is much harder than image understanding because of this temporal sequence, right? How do you? It's not just like every single frame, but it's like sequence of frame and how things um, like correlate with each other over time. So this model was coupled with like processing both the temporal changes, but also the spatial aspect, like things moving in frames, um, like within space and time, right?
Hmm.
Um, Regarding the technique itself, like they leverage some of the pretty well-known methods like self-supervised learning or like unsupervised learning, right? On large scale unlabeled video data set, and that makes them more robust and generalizable, right?
Mhm.
And those model was invented, I say, back in like 2017, 2018, 2020 area, so just a couple years ago. But I think ever since the rise of foundation models, we've seen many more work that actually building like very large scale precision model
Mhm.
on video data, and this is like our bread and butter here at 12 Apps. We've been building our own state-of-the-art video foundation models that we upon and extended copies of the model that I mentioned previously.
Mhm.
And specifically speaking, we have two models. The first one is called Marengo, which is a model that specializes in like retrieval tasks, so like video to text retrieval. And then the second model is called Pegasus, which is essentially a video language model that bridges the gap between video understanding and language understanding. So
Mhm.
yeah, I think like that is only in industry context, but I know that in academic and open source, there's also a bunch of other work to you know um, to be with the foundation model as well. So I think overall, both from academia and industry, there's a lot of excitement um, around this field, and yeah, I'm really going to be excited to see how it evolve over the upcoming years. So.
Mhm. That actually gives me a good segue because I am curious about the two models that 12 Labs released, Pegasus and Marengo. But first,
Mhm.
I would love if you can tell us like briefly about what is Pegasus one model.
Yeah, so Pegasus, the first one, so we introduced this Pegasus model back in no October 2023, and that was
Um,
the alpha
did it,
version, and we
if I understood that right, you said specs model?
no, so I was saying the alpha version of Pegasus model was released back
Okay.
in October 2023, and then the beta
Hmm.
version was released
Okay.
just a few months ago in
Hmm.
March of this year.
Okay.
So Pegasus, it is a multimodal video foundation model
Hmm.
designed to bridge the gap between video content and language understanding, enable
Okay.
the model to interpret and generate text based on video input. Right.
Okay.
So um, well, I think going back a little bit, so multimodal LLM first. So
Hmm.
we all know LLMs, but multimodal LLM is essentially the type of model that can accept multimodal input and generate multimodal output, right?
Correct. Hmm.
We see a lot of these, but like everything from Gemini to like GPT-4o to Lava,
Hmm.
etc. Um, so uh, video language model is a subset of multimodal LLMs that only
Hmm.
focus on the video input, right? And yeah, so because it's a video language model. Um,
Okay.
at a high level, in terms of the architecture, it consists of three major components. The first component is what we call video encoder model, which is essentially the Marengo model, which I talk about in a little bit. This encoder model can process the video input to generate rich embeddings from both the video frames as well as the audio speech recognition data. And these,
Ah, okay.
rich video embeddings are essentially dense numerical representation of the video that can capture all the visual and auditory essence of the video content. Right.
Okay.
The second component of Pegasus is what we call a video language alignment model. So this video language alignment model, as the name suggests, it maps the video embeddings to the corresponding language embeddings, and thereby create a shared latent space where the video and the text representation are well aligned. And this alignment
Hmm.
is crucial for the model to understand the correspondence between what is seen in the video and the
Hmm.
language that describe it, right? So let's say like it's like a like a TV show. So how do we know that like that person on the screen actually speak those dialogue, right? So this is
Hmm.
the goal of
Hmm.
the model, that part alignment. It maps the visual element of the person with the actual dialogue that he speaks, right?
Got it.
And
Okay.
then the third and the final component of Pegasus is what we call the large language decoder model. So this is the very
Okay.
standard LLM part that takes the aligned embeddings from the previous uh, component, and as well as the user prompts in order to generate coherent and contextually relevant text output. So this text output can range from like bullet points to summaries to answers to specific questions about the video content, right? So let's say like
Mhm.
generate a summaries about what's going on in this video. Can you create chapters on break this video down into certain scenes? Um, you know, let's say if it's a like sport match, like what is team uh, like what team is winning, right? Tell me the specific instant where someone score a goal, right? So um, it's really cool because it opened up like the flexibility of type of downstream tasks, right? That the users can accomplish. And so yeah, I think we see a lot of people use it for different format and context, right? Let's say if
Mhm.
you a student, you can easily get a quick report about like the lectures without even having watched lectures. We see people write a quick like operation notes for like a surgical videos that the
Mhm.
doctor just operate, right? So or like something from like more fun application can be like let's say uh, write a rap song, based on this commercial video content, right? So it really opened up like new possibilities for the end user and allows them to um, interpret the video content in a
Mhm.
more creative way.
Right. Yeah, I actually remember trying out the model on your website, and I uploaded like a video short from one of my podcasts, and it was actually able to tell me like what color clothes the people in the video were wearing, and who was on the left, and who was asking more questions, and it's like all those small details, and I was mind blown. I'm like, wow, this is interesting, very
Yeah.
state of the art for sure. So yeah, and now we learned about Pegasus. So now I'm curious about what are like the differences between Marengo and Pegasus, especially if you can talk about architectural differences, that would be great.
Yeah, for sure. So um, yeah, so Marengo is essentially included in Pegasus. So
Okay.
it's a component that makes Pegasus powerful, right? So I think I just mentioned the three
Mm-hmm.
component of Pegasus. The
Right.
first component, the video encoder model, is essentially a Marengo. So
Ah.
Marengo, it's a video encoder model that takes in the video content and generate
Mm.
video embeddings from that video. Architecturally speaking, and there's also a blog post on our website that we can share later on. But um, it is based on this concept that we call gated modality expert. At a high level, the architecture consists of three key components. The first one is what we call visual expert that can process the visual information in the video in order to capture, like say, appearance, motion, and temporal changes within the video.
Mm-hmm.
The second component is an audio expert that can process all the auditory information, right, to capture both the verbal and non-verbal audio signals related to the video. Like if someone's speaking, if there's like a siren, if like a sound, like music going on, this audio expert could be able to capture all those elements. And then the final component is what we call a gated fusion module that assess the contribution of both the visual expert and the audio expert and merge them together into a single unified multimodal representation of the
Mm-hmm.
video.
Okay.
So that's how it works. And this concept of like video embeddings again is very powerful. So like if you know in inside the space for a while, you probably know what embeddings are. But at a very high level, right? These embeddings are very powerful because you can use them to power a lot of the downstream tasks. And in this scenario for 12 labs, the two major downstream tasks that the video embeddings power include semantic video search and zero shot video classification.
Mm-hmm.
So semantic video
Right.
search means that you can um, semantically find the most interesting moment and clips within the video simply by using natural language description. So type in a query, say, find me the scene where Neo got presented, say the blue pill and the red pill, and it could find that exact scene from the Matrix that showcased that exact moment. Video classification is the idea that you can automatically uh, categorize your video content into predefined classes, right? Let's say you have like, let's say you like like a sport league, and then you have so many game footage of like basketball being
Hmm.
played, and you just want to quickly figure out like can I categorize it based on this content. So maybe you come up with like say first class can be like um, all the game that we win. Second classes can be all the game that we lose, right? And then based on that context, the video the model can just like break your video asset into those two categories correctly, right? It's
Hmm.
just a more efficient way for people to um, to manage and categorize, organize the assets. Yep.
Okay, great. You mentioned like some examples around video understanding, but maybe if you can share like one or two use cases of video understanding.
Yep. So interesting use cases for video understanding. I think the first one I want to talk about, and we see a lot of adoption, is in the media and entertainment industry.
I bet. Yeah.
So do you think about like all the film studios, entertainment industry, right? Think like the Disney of the world, the HBO of the world, right? Warner Brothers, right? They make these major blockbuster movies that we see like in the theater. Um, the way they make movies is like they have army of video editors, right?
Hmm.
That edit all the footage that let's say the producers and the actors and do all that stuff and edit it into the final version. And to do that, they need to rely on uh, what the industry called a media asset management system. So this
Okay.
media asset management system like can archive and keep track of all the asset that the end user, in this case the video editors, can leverage. Um, the issue here is like this video content, because they stay so big, there's so many of the gigabyte terabyte of footage that are very difficult to search and utilize, right? And so um, because like our model can analyzing all the visual, audio, and text data in this video, we can automatically classify them with relevant metadata, recognize interesting characters and brands, transcribe speech, and so on, right? And that turn all this unstructured video asset into like structured searchable knowledge that can be efficiently monetized or utilized for the downstream tasks of the video editors, right? So they can quickly like
Hmm.
find the exact most engaging, shoot within all the footage to put it into the final like movie release.
Hmm.
So that's the first use cases. The second is around, I would say like content creators.
I bet. Yeah.
So yeah, so you all know like the rise of like YouTubers and creator
Hmm.
economy of the past few years. So I think the purpose and objective is pretty similar to that of the big blockbuster M&A company. Um, the idea here is like they also make a lot of videos and they want to engage their viewers, the users, right? How
Hmm.
can they create like the best thumbnails, or how can they like shoot the best sort of like footage so that they know that they will increase viewership and thereby get advertising
Hmm.
money, right?
Hmm.
Um,
Right.
and so this is where the business model that I mentioned it become like very hands-on, because it allows them to understanding everything that is going on in their video footage at a very granular level, and that will enable the viewing experience to be more engaging and shoppable. Let's say
Hmm.
if they can like intentionally like design scene with the product in it, like the viewers can like click on the product and buy it, right? Or maybe a location to book a trip somewhere, or like even a song that like users can save it to a playlist, right? And so there's many ways that like these content creators can like intentionally do contextual advertising. So like finding a very interesting
Uh-huh.
context and then insert like an art, like a brand that they can upsell
Hmm.
and monetize it, right?
Hmm.
And yeah, definitely like endless possibilities when you can deeply understand and interact with the video content.
Awesome. Yeah, I like that use case of content creators for sure. I'm pretty sure that's on a huge rise nowadays with all the different
Mhm.
models that are available. So, okay. So Pivoting our topic of conversation here, I learned a lot. It was more like a, video understanding or computer vision 101 for me. But I want to, switch gears to just your experience as in the developer experience engineer here at the company. So I know that you're a head of developer experience at 12 Labs. So what do you think about the AI developer community?
Yeah. Um, so I've been in the field for say about 4 years now.
Hmm.
And I've always been in the AI space, right? Before 12 Labs, I was in the ML ops space working for another company. So like I've seen the rise of like ML, seen traditional approach to like, now generative approach. So overall, I think the AI, developer community is obviously is very vibrant and fast growing one, right? Compared to
Hmm.
like other sector like
Hmm.
infrastructure, cloud, front end, back end, etc. Um, every day we're seeing more and more like developers from other part of the tech stack, right?
Yeah.
With different background, getting more and more interested in AI and looking to add more like AI frameworks into the skill set, the toolbox, right?
Yeah. Hmm.
Um, obviously, like like even like in university, you see the number of computer science majors who specialize in intelligent system increase, compared to let's say cybersecurity or like languages, etc. And this is
Hmm.
obviously because of the how the whole industry has evolved. And so I think what's great is that the barriers to entry keep getting lower, and because like there are more educational resources, more powerful tools, and as well as higher level API for
Hmm.
like say people with non-traditional background to join the field. And you no longer need to have like a advanced graduate degree, say a PhD, right, to build practical AI application. And it was not
Yeah.
the case like even a few years ago because literally just like maybe 3 years ago, in order to like work as an ML engineer, so like a research scientist, right, you have to definitely have a PhD is a minimum requirement because the know-how of like crafting these algorithms, it requires like years and years of like research,
Yeah.
publication, and like very deep theoretical knowledge. But I think like these days, like because the algorithms and more development got structured away as API, um, the way we work with AI application is like just like how we work with like software development, right? We just call an API and then accomplish that. And so like anyone with like a very simple like programming know-how can easily like work with AI application.
Yeah.
Um, so with that, like even though the field is rapidly evolving, um, I still see there's a constant hunger for you know knowledge sharing, collaboration, and support within the community, especially around like events, meetups, conferences, open source um, communities, right? Like these
Mm.
developers are always eager to learn from each other and stay on top of the latest techniques and um, best practices, right? Um, and so for at 12 Labs, as a foundation model company, we obviously put a lot of focus on enabling and nurturing this community, right? We want to provide
Hmm.
developers with the best tools and resources to
Right.
build with video understanding while also fostering connection and learning with the community. So we did a lot of work around like say in-person events, hackathons, also like just this Discord community to facilitate that. I also host like a webinar where we invite a bunch of folks come and speak about the experience with multimodal. Um, and I'm sure like all the other company out there is doing somewhat similar thing as well. So overall, I think the broader ecosystem is probably evolving and super excited to see some of the output that coming from these efforts.
Nice, nice. Yeah, I totally agree. It's like everybody's out there trying to build, and it's becomes so easy to build any AI applications now with all the hundreds of resources available. So, I will leave you with the last question, and this is something that's very close to my heart now. So, what is developer relations for you?
Yeah. Um, you know, um, so I think I get into this field pretty much accidentally. I didn't like seek out like a DevRel role. Right. When I was in grad school, I was like applying mostly for like data science role, and
Yeah.
like ML engineer role, research role, because that's what available, right?
Yeah.
There's no JD that really specify like advocacy work or like evangelism work, right? But I think
Yeah.
like I just got pretty lucky because some of the skill set that I cultivate throughout those just in grad school was actually like become pretty useful for
Mm-hmm.
career path in developer relations. You know, I think back to your question, DevRel is all about enabling developers to do their best work and be
Mm-hmm.
successful with specific technologies, right? So it's
Nice.
a two-way street of understanding the needs of developers and
Mm-hmm.
advocating for them within like our company. At the same time, evangelizing the technology and helping developers to get the most value out of it. A
Nice.
big part of that is like providing an excellent developer experience, right? From the initial touch point on our website to API documentation to SDK to sample apps to like support channels. Every single interaction here should be pretty smooth, intuitive, and well documented.
Right.
Um, Beyond the product itself, I'm also personally focused a lot on building rapport and relationships with the developer community, right? That means engaging with them where they are, whether it's on GitHub, Discord, social media, or in-person events. So we want to meet them on their own terms. Um, it also means going beyond just broadcasting information to actually having authentic conversation. So I want developers to feel comfortable giving us feedback, asking us hard questions, and feeling real ownership over the action about technology. So like every single hackathon events that we host, I always do like user interview after after the event ends, so they can get like honest feedback from the experience working with our technology, right? So that can shape our product roadmap.
Mm-hmm.
So like in summary, like developer relation is about like being the best partner that we can be to developers. It's about empowering them with the right tools, the knowledge, while also learning from them, and then championing the interest. And so when they succeed with using our technology, we also succeed. Right.
Nice. Yeah. I'm gonna steal your, being the partner, being the best partner to your developers line. I really like that one. So yeah, but no, thank you so much for sharing your thoughts here, James. It was a great conversation.
Absolutely. Thanks for having me, and I hope your listeners found some of my perspective um, relevant and insightful.